For today's notes, we're going to answer the question, how do we reflect functions over the x-axis? All right, so first let's just take, for example, a cubic function, very basic. All right, so a basic cubic function can be written in the form y equals a times x minus h cubed plus k. And we've seen that h shifts a graph left and right, and a k shifts the graph up and down. So we haven't really looked at this a yet. To reflect functions over the x-axis, a needs to be negative. All right, so a negative a reflects over the x-axis. So look over here. This is the parent function f of x equals x squared. So this function down here, this is f of x equals negative x squared. All right, so let's look at an example here. Going back to a cubic function again, negative x cubed. So the parent function is a cubic function, right? F of x equals x cubed. So let's go ahead and trace out the points of the parent function. We always go from negative 2 to 2. So negative 2 cubed is negative 8. Right? So negative 1 cubed is negative 1, 0, 0, 1, 1, 2, 8. So we should have those points memorized for our parent functions. Now the transformation is that it's reflected over the x-axis. So to reflect these over the x-axis, we just count how far away they are from the x-axis and reflect them. So here, negative 2, negative 8 becomes negative 2, positive 8. Right? It just flips right over. Negative 1 is now negative 1, positive 1. 0, 0 will stay 0, 0. And these just flip over. So now, this is the transformed function. This is f of x equals negative x cubed. All right, so that wasn't too challenging. Let's try to add in some other transformations. Here we have f of x equals the negative square root of x minus 3. All right, so what's the parent? The parent here is a square root function. Square root. So let's go ahead and plot on a graph just our key points for a square root function. All right, so the square root function, that goes through 0, 0, 0, 0, 1, 1, 4, 2, right, because the square root of 4 is 2. We have these points memorized. It also goes through 9, 3, but we'll leave that off for right now. All right, our transformation for this function is that it's been reflected over the x-axis and moved right 3. So here's the tricky part. Which part do we do first? Do we reflect it over the x-axis first or move it right 3 first? So be sure to take note that we always reflect first and then translate. Okay? So first let's reflect this function, and then we'll translate them each right 3. So 0, 0, this point never can reflect over the x-axis because it's sitting there. So it's been reflected, now we just move it right 3. 1, 2, 3. All right, this next point, we're going to reflect it over the x-axis, so now this becomes 1, negative 1, and then move it right 3. 1, 2, 3. So we're at 4, negative 1. 4, 2 becomes 4, negative 2, and move it right 3. 1, 2, 3. And here we have our transformed function. All right, here, why don't you give it a try? Here's negative absolute value of x plus 2 plus 1. So figure out the parent, figure out the transformations, and remember to reflect first and then transform. All right, so what you should have seen here is that it's an absolute value. It was reflected over the x-axis, then every point was moved left 2 and up 1. All right, and those are our notes for reflections. Reflections.